Today we are going to carry on with these vector questions, and we're looking at the hardest type you can get asked in your GCSE exam. So to begin with, it asks you to find the vector CB. Just like in the previous questions, there is a nice direct route, however there's no information about it, so we have to take this alternate route. It hasn't labelled on the diagram all the key parts, but it gives you the information at the top of the question. So we know to go from A to B, it is this vector 5p. To go from D to C, that's labelled on as this vector P. And finally, D going to A is 2q minus P. Again, it's key to get the direction arrows on. So now we've got enough information to work out what CB is. First of all, I'm going to write the route we're going to take. Well, we went from C to D, then from D to A, and finally from A to B. So C to D is going the opposite way of the arrow, therefore it's going to be a negative P. Then we're going from D to A, which we already know is 2q minus P, and then finally A to B, which was our 5p. If we now collect together our vectors, we've got minus 1p, and again, you can fill in the imaginary number 1 if this helps. Minus 1p minus another 1p is minus 2p, plus 5p gives you an answer of 3p. Then we've got our 2q left over. Part B, it tells you that P is the midpoint of AD. So we know that from P to A is exactly half of this amount. So we know P to A is 1q minus 1/2 P, because P was the midpoint of that vector. The next bit of information we are told, AQ is 2/5 of the entire line A to B, and QB is 3/5 of the entire line. So now we know the entire line was 5p. So therefore, A to Q must be 2p, 2/5 of 5p is 2p, and QB 3/5 of 5p is 3p. It wants us to show that PQ is parallel to CB. So we need to work out what PQ is. So to go from P to Q, we have to go from P to A and then A to Q. Well, that information we've just labelled on in pink tells us this. So from P to A, that's 1q minus 1/2 P, and then from A to Q is this positive 2p. So now if we collect together our vectors, minus 1/2 plus 2 is 1.5 P, or 1.5, or 3/2p. Now we've got what PQ is, we need to write down what CB is. We've already done this in part A. I'm just going to change around the order so it matches up. So I'm going to write my 2q first, plus 3p. So now, if we have a look at these two bits of information, we know that PQ is equal to 1/2 of CB. Because if you multiply everything in CB by 1/2, 1/2 of 2 is 1q, 1/2 of 3 is 3/2, or 1.5. So we have now shown that these are parallel, because we have shown that the vectors are exactly the same. So question 2 tells us that our shape ABCD is a parallelogram. That is key information that you do need, because it tells you that the opposite sides are equal in length and also parallel. That information allows you to fill in that this length here, this vector C to B, is identical to the vector DA. It also tells you that the vector A to B is identical to the vector D to C. Once you've got that information filled in, you can now have a look at the question. So it wants the vector for M to N. So therefore I know my route must be M, B, and then from B to N. The next key bit of information that it tells us is that M is the midpoint of CB and N is the midpoint of AB. So because they are midpoints, I know that it's directly in the middle of my line CB, so therefore MB must be exactly 1/2 of that vector A. Likewise, with BN, it must be half of the vector C. Remember, we're going against the arrow, so therefore it'd be a negative half C. Part B asks us to show that CA is parallel to MN. So, in order to show two lines are parallel, we first of all have to work out the vectors for both CA and MN. So, let's start with CA. So to go from C to A, we're going to take the route CD plus DA. CD is negative C, DA is positive A. Now we need to write down again what our vector M to N was. We've done this above. We actually have 1/2 A minus 1/2 C. I'm just going to flip round the order so it makes it easier to compare our vectors. So you can see here they look very similar, but they're not the same. Actually, what you can do with the vector MN is take out a factor of 1/2. Now you will notice, once you've took out a factor of 1/2, that your vectors are identical. Therefore, these lines are parallel. You have proved that. So in question 3, it tells us a lot of information at the start regarding these midpoints of these different lines. We will come back to that information shortly, but we're going to have a look at what the question's asking first. So it wants you to show again that RS is parallel to PQ. So what you need to do is work out what each vector for both RS and PQ is, and then we're going to examine both of them. So we know to go from R to S, yes, there is a direct route, however there's no information, so we need to go from R to C and C to S. So it tells us that OR is this vector A, and we know that R is the midpoint of the line OC. So as it is the midpoint, we know that RC must also be this vector A. Once we've gone to RC, we're going to go from C to S, and that's already labelled on as this vector B. So now we need to have a look at this vector PQ. So again, there is a direct route you can take, but with no information. So actually we're going to go around. We're going to go from P to A, and then A to Q. So P, A, Q. So again, using the information from above, P is the midpoint of your line OC. So therefore, P to A must be C. We also know that Q is the midpoint of this line AB. So we know that AQ must be equal to 1/2 of this line AB. And we don't know what AB is yet. So actually we're going to take a longer route round to go from A to B to work out what this is first. So we're going to go from A to O, O to C, C to B. So it's going to be 1/2 of this new root. A, O, O, C, C, B. We know that A to O is negative 2C because we're going against the arrow. We know that O to C is positive 2A, and we know from C to B is positive 2B. So now, as these numbers are quite nice, we're going to get rid of that 1/2 by timesing each term inside the bracket by 1/2. You'll notice this works quite nicely. We have minus C plus A plus B. So now, if we put all this information together, we know that PA was this vector C, and then we know AQ is what we've just worked out below, which was minus C plus A plus B. So if we now collect together our terms, we would be left with A plus B. So because these vectors are the same, they are parallel. So here in question 4, it's asked us to show whether BCD is a straight line. To show anything is a straight line, what you need to show that the gradients are equal and they share a common point. Because if you can show that your gradients are the same and they both pass through the same identical point, that will tell you that the line must be straight. So we need to show that the vectors BC and CD have the same gradient. So in order to show BC, there's the quick route, which we have no information about, and the slightly longer route, which we're going to take. So we know that BC is equal to BA plus AC. If we put this together using the information on the diagram, we've got 5A minus 2B, and from A to C we're going against the arrow, so we flip our signs. So that becomes negative 3A minus B. If we now collect all of our vectors together, 5A subtract 3A is 2A, minus 2B minus another 1B is minus 3B. We're going to do a similar process for CD now. So to go from C to D, we're going to take the route CA and then AD. So CA plus AD. We know that CA is this vector 3A plus B, and we know that AD is this vector 3A minus 10B. If we now collect together our vectors, we've got a total of 6A minus 9B. So here, if we again try and take out a common factor so that our vectors inside the bracket matches to BC, you can see we can take out this common factor of 3, and our vectors inside the bracket matches to the line BC. That then tells you that the gradient is the same, and because the gradient is the same and they both share that common point of C, that tells you that it has to be a straight line. I know on Mathswatch the answer they give is slightly different, but the way we've done it is a perfectly valid way to prove it in your GCSE exam, and it would be the way that I would teach you how to answer this question. So please don't worry if it's come up as an incorrect answer if you've done it the same way as what I've shown, because that is a perfectly valid method. So question 5. This is probably one of the hardest questions you would ever face on a GCSE exam, and is therefore typically one of the top grade questions. So, having a look at part A, it wants us to express FD in terms of M and N. You'll notice that F isn't on the diagram at the moment, but it does tell you that F is the midpoint of your line BD. So again, I'm just going to mark on that point F, which is the midpoint of BD. So it wants us to work out what the vector FD is. Well, that's identical to the vector BF because F was the midpoint. So actually, if we can work out what the vector BD is, we will be able to work out what BF or FD is, because we know it's exactly 1/2 of the vector BD. We know that BD is equal to BC plus CD. Again, because this is a parallelogram, opposite sides are equal and parallel. So we know that this vector here must be M, and the vector down here is N. So BD is equal to BC, which is our vector N, subtract M, because we're going against the direction. So now FD must be exactly 1/2 of BD. So therefore 1/2 N minus 1/2 M. So looking at our next question, it tells us that E is the point such that ADE is a straight line with AD to DE in the ratio k/1. So first of all, I'm going to draw that point on my diagram. So we know it's a straight line and our end point would be E. We don't know what that ratio means yet because it's asked us to work out what the value of k is. However, it's told you another bit of information. It's told you that FE is this vector 2n minus 1/2 m. So again, if we fill in that information there, it tells us that FE is 2n minus 1/2 m. I'm just going to make a note of this. So FE is 2n minus 1/2 m. And we've worked out in part A that FD is 1/2 n minus 1/2 m. So now we need to work out what the vector DE is. So we know that the information from D to F, and we know the information from F to E. So from D to F, we're reversing our vector FD, therefore our signs are changed. And we know that FE is 2n minus 1/2 m. If we now collect these together, you've got negative 1/2 n plus 2n, which is 3/2n. You've got positive 1/2 m, subtract 1/2 m, which is 0. So if I draw out what information we are now told, it will make it slightly easier to visualise. So we've got our point A, we've got our point D, and we've got our point E. We know that A to D is this vector 1n, and we now know that D to E is this vector 3/2n. So if I have a look at the ratio of AD to DE, I know that it must be 1 to 3/2. However, it's asked for it the other way around. It's asked for it something to 1. So therefore, if I divide both sides by 3/2, I will get the right hand side equaling to 1, and my left hand side, if I remember, when I divide by a fraction, I actually flip and times, so it's 1 times 2/3, or just 2/3. So therefore, my final answer, k, must equal to 2/3.